Welcome to MATHFREAKS. So today we are going to discuss this question of limit, that is continuity and discontinuity, along with application of AOD. This is a combination of two topics. Very interesting question. The question says like, let continuous function fx, it is defined over a range of x where p is not equals to 0 if a line L touches the graph y equals to fx at 3 points, then the value of this. Okay, so first of all, the question says that f of x is continuous. Okay, now for a continuous function, we know that limit x tends to a f of x. If f of x is a continuous function, then this is a condition and limit should exist of fx, right? If f of x is a continuous function, this is the basic definition of continuity, right? Okay, another thing, if you look at this defined functions over different ranges of x, we see that none of these functions are uh, undefined for x, for the extreme values of x. Like here it has been given that this is fx for all values x less than or equals to -2. Now if I put the value of -2 in this function, we are not getting any undefined value, right? So we can say that we can directly put the limit, like x equals to a, we can directly put. So the given functions is something like x square plus 10x plus 8 for x less than equals to -2. You are getting my point, right? This function is not undefined. If I put x equals to -2, then there is no like we can directly put the value of x equals to -2 here. So and the another f of x is defined over x belongs to open -2 to 0 open, that is px square plus qx plus r, that is for -2 to 0 open not included, that is. And the third and the final is x square plus 2, 2x for x greater than equals to 0, right? Okay, now back to the point that I was trying to make. We can directly put the value of the extreme. And one more thing, that is, if this and this is continuous, then say this one is f1 and this is f2, right? So f1 at a must be equals to f2 at a, because they are continuous, right? There is no break in that function, it is continuous. So it will give same value at the same value. The f of x will give same value for same x, right? If that is true, then we can put that f of 1 at -2 should be equals to f of 2 at -2. If that is so, we can say that 4, if I put -2 here, 4 minus 20 plus 8 equals to 4p minus 2q plus r, correct? Again, if this and this is also continuous, then again say this is f of 3. Okay, let me write it more clearly. So what we told is this, say this function is f of 1, this function defined is f of 2, and this function defined is f of 3. So if the f of x is continuous, then this two function must be continuous. So f of 2 at a again must be equals to f of 3 at a. If this is also true, then see the extreme value 0, 0. So we should uh, write that f of 2 at 0 must give the same value as f of 3 at 0. If that is also true, we can say that r is equals to 0. From here we directly get the value of r, that is 0. So our among the three unknowns, our one unknown has been found. Okay, now we come to the second part, that is p and q. From this we get that -8 equals to 4p minus 2q. Like r is already 0, so there is no point of writing r. Okay, now how to find p and q? This we can get from the second part of the question, which states that a line L touches the graph y at 3 points. Okay, now um, touches the graph at 3 point. What line touches a graph? What type of line touches a graph? Its tangent. So we can say that the line L, whatever the line L is, it is a common tangent to the three graphs. Okay, that is what it is trying to state, that L is a common tangent to the three graph, that is f1, f2 and f3 that we defined. If that is so, let us take say f3, right? Now we are trying to find the line L, then we can easily find the values of p and q. That is not a big deal. So to find the tangent, let us take f3, that is x square plus 2x, if I'm not wrong. Yes. Now here comes the, okay, up to this there was continuity. The concepts of continuity, very basic, that is from definition. If you only read of continuity, then also you can come up to this part. Now starts the application of derivatives. Now when we try to find tangents, right, what we do, say f of x is a function, what we do, we find say we have been asked to find the tangent of f of x, say at point alpha comma beta. So what we do, first of all, we find the slope of the any line touching the curve at alpha and beta, and to find the slope we just differentiate it with respect to x, that is f dash of x. And to find the slope at alpha comma beta, we put the value of x equals to alpha, at x equals to alpha, then we get the slope, and then somehow using coordinate we find the value, sorry, the line, that is the tangent. Similarly here also we will do the same. First of all, we will differentiate. So f dash of 3x we can write with respect to x, I'm directly writing, that is 2x plus 2, correct? Now this is the general what to say, slope. Say if f3 is a graph, then if we are asked to find the slope at any point of the graph, this is the general form. Like if, say, here's a point, say p dash, if we are asked to find the coordinate of sorry, the slope of the line at p dash, we can just put the coordinates of p dash here and we can directly get the slope. So this is the general form of the slope to f dash 3 at any point, right? Now we do not know where the line L is touching the graph f3 or f2 or f1, right? So let us assume that the point where f3 is touching, sorry, the line L is touching f3 is some point p. So let us assume the point where line L touches graph f3 say has x, that is abscissa, to be t, right? This is the parametric, right? We have taken a parameter of x, that is t. Now if I put t, okay, now why it is important to assume this part? Otherwise, what a general mistake is that, say you did not take t or a specific value of x, what you will do is say, now we know from the coordinate that y minus y1 upon x minus x1 equals to m, right? Now if you put this here m, then you will be confused that this is also a function, a linear function in x, and this is also a linear function in x. So you are getting y as a quadratic, and tangent, obviously being a line, cannot have a equation of quadratic, right? Do you understand what I'm trying to say? If you put this formula in here, you will get confused that this is also, m is also a linear function of x, which is not. M is here a fixed value, but you will get confused if you take this general form. So you will finally get y as a quadratic, which is not true. How can a line have a quadratic equation, so which is not true? So that's why, to remove that confusion, we take this parameter t as x. No, now say f at t this is the slope at the point, say P. Okay, let P be the point where the line L touches the graph, right? So the slope would be 2t plus 2. Correct. Now what? Now, okay, now we can make if okay, if I take x as t, what would be y? Think. Say this is the graph of f3 and this is the point P, right? So a line is touching, so I have taken x to be t, so what would be y? Simple, put x as t in this equation, so y we get as t square plus 2t. And from this equation, now we can use this equation and get the equation of tangent in parametric form. So that would be y minus, if I put this value, that is t square minus 2t upon x minus t, that that would be equals to t plus 1, right? The slope. Now you have to solve this, so if I do, that would be 2 plus 1 x minus t. So y is equals to minus t square, right, minus t square. Okay, a small mistake, that would be t square plus 2. So accordingly minus minus, so we can directly cut this, and this is our final equation in parametric form. Okay, now since it's common tangent, so this line, that is y, will also be a tangent of this particular function, that is f1. So y equals to 2t plus 2x minus t square is also a tangent to f1x, that is x square plus 10x plus 8, if I'm not mistaken. Yes. So what we can do is, now to very simple, we can, this is also equals to y and this is also equals to y, so we can directly replace the value of y as 2t plus 2x minus t square equals to x square plus 10x plus 8. So from here we get x square plus 8 plus t square, and here 10 minus 2t minus 2x. This is it, right? And since it touches, the line L touches the graph f1, so obviously the discriminant would be 0. So this would be 8 minus 2t whole square minus 4, 8 plus t square equals to 0. That would be 64 plus 4t square minus 32, t equals to 32 plus 4t square, so 4t square gone, and 32 equals to 32t, so basically t is 1. Correct. So we got our parameter, that is t equals to 1. That is, we can now say 2t plus 2x minus t square, right? So y equals to 4x minus 1. This is our line L. Now very simple, if I got my line L, now we already had one equation, that is this one, right? This is our equation number 1. Since there is two variable, we could not solve for value of p and q from this single equation, right? or we will get multiple values of p and q. So we needed one more equation that we can get from this one. So px square plus uh, qx, right, equals to say 4x minus 1, since y, right? Again discriminant 0, so px square plus q minus 4x plus 1 equals to 0. If I again make d equals to 0, what we will get? Q minus 4 whole square minus 4p equals to 0. So q minus 4 whole square equals to 4p, right? And we also got 4p minus 2q equals to minus 8, if I'm not wrong, the equation 1. Yes, 4p minus 2q equals to minus 8. So again replace the value of 4q. So q square plus 16 minus 8q minus 2q plus 8 equals to 0. So q square minus 10q plus 32 equals plus 24, sorry, it's to 0. And simple factorization, that would be q minus 6 and q minus 4, if I'm not wrong. This would be 6 4, yes, right? So q can be either 6 or 4. Now if so, what would be p if say q is 4? From this equation, if q is 4, then p we get 0, right? Q is 4, p is 0. And if q is 6, if I put 6 here, then p is 1. So p plus q plus r either can be 6 plus 1 plus 0 or 4 plus 0 plus 0, that is 7 or 4. Now look at the options. So only 7 is given here, so ultimately we can say the answer is 7. I hope you understand this question. This was a beautiful question. Just keep in mind that the concepts of basic definition of continuity and some basic applications of derivative, right? Thank you for watching.